Hi, my name is Adam from Elprotronic. I'll be showing a demo of the GangFlasher-ST. The GangFlasher is an in-circuit programmer for the STM32MP1 processor that can program eMMC memory, SD cards, NOR memory, SPI NAND, and OTP memory. And in this demo, we'll be programming the Octavo BRK board using the starter package available from the website. Okay, so let's start off here by going over the hardware setup that we have. So we have the Octavo board on the left. We put all the pins to the rightmost position so that the DFU will boot up. And we've also connected a UART connection here that will show up as a COM port so we can actually have access to this board over TeraTerm. Now, okay, so on the right, you have the GangFlasher-ST software, and you'll see that the DFU is showing up indeed. So what we've downloaded here is this is the image that you can get from the website, from the Octavo website for OpenST Linux. And now within that image, there's everything. There's all the files that represent each of the partitions that we want to program, and there's the partition table. Now what we actually want is we want to get access to the first stage bootloader and the second stage bootloader because this is a custom board. So this configuration is not pre-programmed into the GangFlasher-ST. So what we're going to do is we're going to open this image, and this is done automatically. You open it here, select the image, and it will automatically open up all those files that represent all the partitions, and it will generate a TSV file. And a TSV file will represent the mapping of each of those files of how they are programmed into the SD card that's on the board. Okay, so this is the TSV file that was generated based on this image file. And a couple of files there are interesting that we're going to use the custom definition of the board. So we're going to call this Octavo BRK. And in order to boot our fast bootloader, we need the first stage bootloader and the second stage bootloader. So this is what was extracted automatically from the image file. Once this is uh, specified, we can select the Octavo BRK, and now we're ready to auto program. So what will happen in auto program is we're going to create a partition table first, and we're going to program all the images, and then we're going to verify them. So as I mentioned, we are creating images for the fast bootloader. So this was done by referencing the initial partitions in the image that have the device tree for this custom board. And this is something that always has to be there. So that's guaranteed to be there. Otherwise, this image wouldn't be actually be able to boot on the Octavo board. And now what we're seeing happening is that the partitioning of the SD card happened over here. And now each of the partitions is being programmed. So the first partition is programmed very quickly, and then after that the bigger partitions will program. Now I'm going to reference this video here on the right. This video shows how the programming is proceeding, and on the left we see trays that you can get just by connecting via UART to the board. And here you have the main GUI from the GangFlasher programming each of the partitions. So the actual real good speeds will get on the bigger partitions because you don't have the overhead of actually opening and closing the device. So we'll see that on this board, because it takes some time to program, I'm going to speed it up by a factor of 10. But the maximum speed we're going to get here is about 13 to 14 megabytes per second, and that's because this board is actually very similar to the DK1, DK2 boards from ST, and those operate at a high-speed mode that's limited to programming. So this won't program as fast as what we've shown, for example, on the EV1 board where we could program up to 40 megabytes per second. Okay, so once the programming is done, we'll see that it took 300 seconds to program 4 gigabytes of data at an average speed of 13 megabytes per second. Now the second thing that happens after that that's necessary is to do verification. In verification, we're doing checksums and we're doing PSAs for each of the devices. And here, because we're reading, this will be proceeding much faster, so we're going to be going at about almost 23 or 24 megabytes per second. And I'm going to speed up this part as well. so we can get to the interesting results. Now, as I said, for the high-speed mode on the DK1, DK2 boards or this Octavo board, the maximum read speed is about 25 megabytes per second. Okay, so we're done with verification. It took about 170 seconds to verify 4 gigabytes of data. So in total, everything, read, write, um, of all the images, the writing and the verification was in total around 500 seconds. And once the verification passed, this means we're actually ready to boot into the starter package image from Octavo. So now, this is another video here. So what we have to do is we have to change pin 1 and WP pin to the left position to boot. Once we do that, we can reboot the board. So now we're rebooting the board. It's booting into the image provided by Octavo. And once that's done, we can look at the partitions that were created. So this is what you could expect to see if you were programming with some other utility like Etcher, for example. If you took out the SD card physically, you programmed it, and then you put it back in and you reboot it, this is what you'd see. So now over UART, because we actually have RX and TX connected, we can log in, and we'll see that these are the drives that were created with our partitioning and programming, and everything is what we'd expect it to be. Thank you for watching our demo of programming the Octavo BRK board using the GangFlasher-ST software.